Welcome to BAWASHIR automation class once more. So this is the file we had last configured for Siemens. Remember, we named this one BS back sensor, FS front sensor. Then we named this one FX, that is forward, and renamed this one RX, that's reverse. If you forgot, the video is quite up there after the Mitsubishi concepts. And also, if you are keen with every content, you should be having it within your files or gallery. So we are going to see how to connect it direct away to our HMI that we had created, which is, I'm just going to open here an existing project. I'm gonna close this first. So the project is already there. I'm just going to open and start from where I had stopped. So after opening like this, you come here to project view. Okay, so as you see, we have already our PLC, the first device. We have our HMI, the first device. Let me view the HMI where we had stopped. So after drop down, you come here to screens. We have here conveyors control. You double click on it. It's the only screen that we have. So we are going to do it in bits. We do as we test and confirm what happens. It takes time, but at least it leaves everyone acquainted with what is happening. So I wanted to remove this root screen, but I know how I'm going to remove it from the error instruction. So this one, I'm going to enlarge it here a bit. So I have these two copied and pasted things. Just click on them and click delete. This is just an empty space. So we are going to add functionality to these buttons of ours. But adding functionality to these buttons, we first have to create the connection control circuit. So we are going to come here to PLC, drop down, come to program blocks, just as usual. The good thing with HMI, double click on main. Double click here. The good thing here in HMI designing and HMI design, it still gives us the art of reviewing how to deal with the ladder logic, because you cannot link functionality to HMIs unless when you know ladder logic. So that means even though when you were doing only ladder logic and you didn't capture, still you can use this chance because it is like a repeat. And so I'm going to start having here something. Now remember, here in PLC addressing, we have two types of addressing. We have internal tags and the external tags. Internal tags, I mean, those are the bits, memory bits that we use inside the PLC. We don't need to connect the physical devices. But external tags, those are like inputs and outputs, which need to be connected direct to the PLC. For example, buttons, sensors, and the lamps, watt, coils at the output. So remember, with the external tags, we only have I, 0 point something or 1 point something, where we use QI, meaning input, I meaning input, then the output we use Q. Then anything, most of the things, in like for example, internal tags, there are mostly memory bits and the registers. So here we are going to come, since we are going to use HMI, these buttons we don't need to connect them physically. It is just something communicated to the PLC using a software internally, so that is an internal bit. So with the internal bits, we are just going to use memories. So I'm going to have here normally open. That one is going to act as a manual button. Then this one is going to act as a manual coil, a relay. Then it is going to hold itself. Then I drag and drop here to complete that one. Then this one is going to be normally open, normally closed for the automatic. This is now switching to manual. You are going to see when I'm defining the tags. Let's first draw the second one, just in the same format. Then I have here branch. Then I have a normally open, and I just drag and drop this branch here. So this one, I'm going to call it a manual button. Then this one, I'm going to call it automatic button, auto button. So remember, even though we are following Siemens, but remember with the programming, ladder logic or circuitry, it cuts across all. It is all the same. Though sometimes I may do a different circuit for the other brand and a different for this brand, just to try to show you that circuits can be drawn differently. Or sometimes I do the same, also trying to show you that the same circuit can work in another brand. Only what differs is the appearances of the software, but circuit development remains the same. Because that's why I want you always want you people to always analyze all clips. Even though you're doing Mitsubishi, also watch for Siemens. Even though you're doing Siemens, also you have to watch for Mitsubishi so that you can see the comparisons, differences, and the similarities. So here I have, this is going to be manual relay maybe, or manual memory. Then this one, spelling for manual. Spelling does not matter, but for reference, I have to do something that I'm going to understand. This is manual memory. Just a self-holding for this one. That means when I click manual button, it is going to engage manual. Then when I click automatic button, it has to break the manual functionality and engage automatic. Because here, this one automatic button will have to start this one. Then here is going to be broken by manual button. I see. Then here is going to engage the auto memory. The auto memory, then here it is auto memory self-holding itself. So that is just a logic of switching between the manual and the auto. So now you can define tags. Here define tag. We are going to have here global memory. It's going to give us memory 0.0. It's a define. Then we are going to define tag here. Also global memory, define. Then we are going to define next this one. Also global memory. You see, as we define this way, the one we have given the same addresses, it is defined automatically. Then remaining this one, global memory, so define. You see, now everything is defined, and that one is there, it's finished. So what we are going to do is, once we click the steps, the correct steps is go to compile. After compile, start simulation. After simulation, download to device. But now, even if just you do simulation at once, it is going to compile by itself the program. Then it is going to start the simulation PLC. After starting the simulation PLC, is going to prompt you to download the program to the PLC. Then it's going to prompt you to start the PLC into run mode. Then you'll be ready to go. So let's first analyze this one. So remember, I told you what this project here we are going to connect to Factory IO, and what you are intending to connect to Factory IO, you must start with a template. If you don't know the template to use, share with me the version of TIA portal that you have. Then I guide you on how to get it is template. But those with 15 and 15.1, I already shared with you the template file, unless when you lost or when you forgot how to go about with it. I'm still available. Start module, finish. So you see the PLC is already in run mode. That means I'm going to minimize that one. I name minimize here. So the other thing is you can, to analyze what is happening, remember I told you can put your program in monitor mode. You just click these glasses here. Though still it can work even if you have not put in monitor mode. Monitor mode is just for you to refer the functionality to the ladder logic. So now from there we are going to come here to our conveyor screen. Before we put the screen into functionality, we come down here to HMI, which is this one is our HMI device. We come here to screens. Before we go there, we are going to create HMI tags. We are just going to use default tag table, double click on it. So here we are going to start here with a new tag. There we are going to have manual button. It is not necessarily that you have to name it the way you named in ladder logic, but me, for easy simplicity, that's what I'm going to do. You can name it something else, provided you are going to remember that it's supposed to be connected to manual button. Then here I'm going to have auto button. Then here I'm going to have manual memory. Then I'm going to have auto memory. I think so far those are the bits that we have put in ladder logic. Sometimes you may not need so much to understand this English. Only what you have to know is so here we are going to HMI connection 1. Remember we did this connection when we were starting to draw our HMI components. Internal tag means that the button is going just to work inside the HMI, but not connecting to anything in the PLC. But when you make HMI connection 1, which is connected to PLC 1, that means the button is going to control something inside the PLC. We also have those buttons that just work on the HMI without controlling the PLC. For example, changing screen and XYZ. So this one, manual button, it is going to connect to a PLC tag called, you come here to PLC tag, it's going standard variables called manual button. You see, I named them the same so that I can easily identify manual button will be connected to the corresponding manual button. But it's not a must that they both have to have the same name. So we go. Okay, so here auto button also is going to connect to the auto button. You say okay. This one is manual memory. Is also going to connect to manual memory. You say okay. Then auto memory. What is this? Auto manual. No problem, but let me just correct mine. So auto memory is also going to connect to auto memory. You say okay. So we have finished. Now what we have is to assign our buttons, that one. So we have here manual button. When you click on it, raise here these properties manual. You double click on it to have the properties here. This property window can be raised up if you're not seeing. So we are going to come to events. With the buttons, they are controlled with events. So you are going to add, since it's going to act as a push button you press and release. You press and release. So when you press, we are going to add a function. How do we add a function? So here we are going to edit bits, since you are dealing with the bits. Set bit. Set bits mean that turn the bit on or off when you turn the bit on. So here, set bit is going to deal with auto button. This is HMI tags now, not PLC tag, but HMI tag. So auto button, I mean manual button, say okay. Then when you release, this very button is going to have a function. You double click, the function drop down is going to reset bit. So you have set bit and reset. When you press, it sets. When you release, it resets. I had a tag. It is the very same tag of manual button. You say okay. I try to go slow, even those ones who didn't understand introduction the very first time. Still, you can pick from here. Then we are going to go to this one, automatic. So when you press, it is just going to be the same. Set bit. Then for it, the tag is going to be auto button. You say okay. Then when you release, the function is set bit reset. Then here it is the same auto button. You say okay. Now we come here to, remember this one was just a circle drawn from base objects, from shapes. So shapes, we give them animations, and we have movements and display. Movement is when you have moving objects, but here we just need display. Double click and give appearance. Say okay. So we are going to give it a tag. This is manual memory. Say okay. Then now we are going to add here, when it is 0 means when it is off. It is going to have that color which is having. So here also set the same color. I think it is that one. Yes. Flashing, no flashing. Flashing means that the button will keep on blinking. Though off, so when you set when it is off, it will be blinking when off. So here add new 1. Say 1 means when it is on now. So when it is on, you can give it to something like green, or yeah, something like light green. Then also here the same. Yeah, I think this the same color. So that one is done. So we also come to this one, add the animation, display. So okay, give it a tag. A tag is auto memory. You say okay. Then add when it is off. It is having that initial one. You say okay. Then add when it is on. It is also having light green. Make the same here, also having light green. So I think that one is finished. So for now, let's first try only those ones. Like these ones we shall also add later. So after that one, just click here. We are going to come here to start simulation. Remember, our ladder logic part is already in a simulation. Oh, we have software compilation completed. Errors 1, warning 0. So we have an error. So where you see the green is where the mistake is. So just double click here. It's going to give us the root screen thing. It's not okay. I'm just going to press delete. So that right click here, say delete, so that it goes away. Then I'm going to say start simulation again. Errors 0, warnings 6. Warnings means there are some components, they don't defer it from running, but they are not proper. So finally, it is here, it has come, it is this one. So how comes this one is already on? Let me see, automatic. You see? So when you click automatic, automatic comes on and breaks manual. When you click manual, manual comes on and switches off automatic. Hope you can see. Hope you can see. So that is what you have tried to come up with. Since I told you can have monitor mode and see what is going on. So here it is already in manual. You see the green. So when I minimize this one, you see when I switch to automatic, this one goes off and switches on this other side. You see. So the rest of the circuit, coming up with how to connect the rest, that one is now according to your creativity in circuit development. The only guide was how to connect these buttons and these shapes to give them functionality, how to connect them to the corresponding ladder bits and symbols, connecting the HMI to this simulation, creating tags and so on. But now, when we come to something like designing buttons, coloring, giving them shape, positioning them, that is your art. Also, creating the circuit to give a certain functionality, that one is also your art. But not to lengthen the video for now, let me stop here. I first compile this one. Then after, we are going to start from there, the next clip, so that we program the whole thing and finish, and also connect our factory I/O and see how everything moves. Okay, see you when you see me.